Today's lesson we're going to talk about annuities. Mr. Watts paid for his 12-year-old granddaughter's future university expenses. Oh, that was very nice of Mr. Watts. Mr. Watts deposited $3,000 at the end of each year for 7 years in a savings account that paid interest at 7.5% compounded annually. Now that's pretty nice. Not many of us would get that rate. His first deposit was on December 31st, 2010. What was the total value of this investment after 7 years? So this question is different from ones that we've done because we're talking about making a deposit regularly over and over again, not just once. Everything we've done up to now has been, here's my money, here's my principal, I'm putting it in the bank, it's going to sit there and I'm not going to add to it. So that's what an annuity is, and that's the title of today's lesson. This type of investment where fixed amounts are deposited or paid at regular intervals over a set period of time is called an annuity. All annuities we'll be discussing have payments made at the end of each compounding period. So just to keep it consistent, he's going to pay at the end of each year, he's going to put his $3,000 in. So that's going to be on December 31st at the end of the year. So let's take a look. Let's say this is a timeline here of the amount of time his money's being compounded. So the beginning, 0, nothing's happening. They didn't deposit anything at the beginning, but at the end of the first year, so the December 31st, right? So the first year is pretty much over on December 31st at the end of year 1. So at the end of 2010, he is depositing $3,000. Now that $3,000 is staying in the bank for this whole timeline, that $3,000. So let's just talk about that $3,000 first. So here's all the years that it's in the bank, all 7 years. This deposit of $3,000 after the end of 6 years, now not 7 because he's depositing at the end of the first year. So he deposited this at the end of 2010. So he's leaving it in the bank, and it's actually staying in for 6 years. What's that? How do we calculate the amount of just that $3,000? So that's using the formula that we already talked about. That's just the compound interest formula, P bracket 1 plus I to the power of n. So there's a formula, there's the principal, that's the $3,000 he put in. There's his interest rate was 7.5%, but as a decimal 0.075, 1 plus that, and the exponent is a 6. As explained here, it's the end of 6 years. So that's what that first installment of $3,000 will be worth by the time he takes it all out after 7 years. That money will be worth, when we calculate this, will be that amount. So let's look at this again. At the end of the next year, he deposits another $3,000. That stays in the bank until the end, and it has a very similar formula to this one. The only difference is the exponent. It won't have been in there for 6 years, it will have been in the bank for a total of 5 years. Third year, at the end of the beginning of the third year, the end of the second year, again, he deposits $3,000. Sorry, end of the third year, he puts that money in, and that is in for a total of 4 years, and so on. We're going to skip the next 2 here. He does it again at the end here of this is the end of this year. He puts another $3,000 in, another $3,000, sorting over 2010, 2011, 2013, sorry, 2011, 2012, 2013, 2014. So every year, at the end of every year, December 31st, he's putting in the $2,000. So here's his other $3,000 he deposits. Let's take a look at this one. This one is going to be in the bank for a full year. He puts it in at the end of the 6th year. He puts it in, puts the $3,000 in. It stays there for a year. So the exponent is a 1. So it gets that interest just once because it's compounded annually. So one time he's going to get that interest. What about the next year? So at the very end of the 7th year, he deposits the $3,000. But basically, since he deposits it at the end of the year, and we're looking for the value of the investment at the end of 7 years, that doesn't get any interest at all. It's just the $3,000. Or you could write this bracket out, 1 plus 0.075 to the power of 0 if you want to. That's really technically right there, but anything to the power of 0 is just a 1, so it's not, we don't need to put it there. So that's what's happening with that. Now all of these in red. If we add them all up, the sum of these amounts will be the total amount in the account after 7 years. We're going to list that as a series, going back to sequences and series units. So here's just a snapshot of that last part of the slide. So as a series, remember this was written like this for geometric, a to the power, sorry, just a plus a to the power, a times r plus a times r to the n minus 1, and so on. And this will go on. So that will be a geometric series. So for us, the A, for this question specifically, A, our initial value, that's our 3,000. That's this number in the front here. So first one we'll use, this will be our first one here. That's going to be just $3,000. That one gets no interest. That goes there. Then the one before it would be 3,000 times our common ratio. So our common ratio is 1.075. and so on. So we start with a first term, there's a second term with the ratio once, there's the ratio squared, and then all the way to the end, this one is here. That's this one here. So that is a series. Remember, a series is a list of numbers or terms that you're adding together is called a series. So that's a series right there. This is a geometric series with 7 terms, and for this particular example, A is equal to 3,000, and our common ratio is 1.075. And remember, this formula right here, this comes from your final amount is equal to the principal 1 plus I to the power of n. So there's a lot of similarities between the formula that we did in a past lesson and the one we're going to do today. So let's use the geometric sum formula from last unit to determine the total amount. So here's that formula, and we're going to sub into it. Our A, what's our A? Well, it's right there, it's 3,000. Our common ratio is 1.075 minus 1. So this was the formula we already know, and you put all of this into your calculator, and you get this number here. But since it's a word problem, we need to answer as a sentence, and the question was originally about Mr. Watts's investment. After 7 years, Mr. Watts's investment will be worth $26,361.97. That's the total value of his investment. Now, a lot of that money he put in $3,000, right, over and over and over again. So a lot of that money is money he put in, but the rest of it is the interest that he made on that money. What we have to do now is, if those of you who are going into finance, you would never see this formula. We have, as you know, different letters that we use for finance, so we're going to replace them. The first one being S subscript n. That's the sum of n. That's just your final amount. So that's just going to become like your capital A. That's your final amount. Our lowercase a that we used, if you look up here, look at that's lowercase a over and over and over again. That's what we're going to use. Now this is new, it's a capital R, and that capital R means a regularly occurring deposit. So it's a regular, Mr. Watts is regularly putting in $3,000. So that number that we see here, that we saw in this geometric series over and over again, we're going to use an R for that. And the lowercase r that we used to use here for common ratio is now, because we're talking about money, it's going to be 1 plus your interest rate. So that's just your R is equal to 1 plus your I, and I is 0.75. So here is our new formula that we use in the finance world. Future value of an annuity. There's your capital A. So it all comes from, it's like the exact same formula you use for geometric series. We just have different variables, so it looks different. But in any case, you have to memorize that formula. And here's what everything stands for. We talked about that. An ordinary annuity is an annuity where the payments are made at the end of each interval. And that's all we're going to do in this course. We won't be saying 1 year you're putting your money at the end, another year you're putting it in halfway through. We're always going to say it's at the end of each term. It might not always be a year, it might be semi-annually or something, but it's always at the end. Example 1, for 10 years, Sheila deposits $750 at the end of every 3 months in a savings account that pays 8% per annum. Remember, that's what that means. That means per year, compounded quarterly. Find the amount of the annuity and the total interest earned. So she's getting 8% over a year, but it's broken up into quarters. So the bank is going to give her some interest throughout the year. As soon as I see this situation, you've got money being deposited over and over and over again, I know this is the formula I have to use. So let's start with that. Now we need to fill in the blanks here. We need to get some of our variables filled in. Well, starting at the top here, this is an easy one. She's putting $750 in regularly, so that's going to be our R value. R is 750. So we've got the R. What about the A? Well, that's what we're looking for, and the question says right there, find the amount. So our A is unknown. We don't know that value. And what about, we need I or N still. Let's go to I. The interest rate, remember, is the percent. The percent we're getting is 8%. That's 0.08. And we're compounding quarterly, so we have to divide that by 4. So our I is actually equal to 0.02. That's I. And N is the last one. N is the number over here, number of compounding periods. Number of compounding periods, so we've got 10 years quarterly. So 10 years, and her money is being compounded quarterly. That's 4 times a year, so our N is going to be 40. So let's substitute all of that into the formula. All right, we substituted in everything. Now this is all work to be done on your calculator, so make sure you are either using brackets on your calculator or you're typing it into your calculator with the order of operations so that everything is done in the right order. And do that, and you should get 45,301.49. And the question said, find the amount of the annuity. This is the amount of the annuity. This is what it's worth. And the total interest earned. So that's not all interest. She put in $750 over and over again, right? She put $750 in every 3 months for 10 years. So most of that's her own money anyway. She hasn't earned interest on it. This is the important part that everybody wants to know. How much money did I make? I already know how much I put in, but I want to know how much money I made. So how do we figure that out? The total interest earned. Total interest earned. Probably you've all figured it out already by now. Total interest earned is going to be, so how much did she put in? She put in 40 times, she put in $750. And we want to subtract that from that number that we just found, 45,301.49. So this is what this would be done in brackets. So you're taking the amount that she earned and you're subtracting everything that she put in. And when you do that, you'll get the total interest earned. So her total interest earned is going to be $15,000. So that's pretty good interest, $15,301.49. So that's the total interest earned. And the amount of the final amount of the annuity is $45,301.49. Okay, let's try one where we don't know this number here, where we don't know the regular amount to be deposited. Example 2, Danielle's an electrical engineer, and I know some of you want to be electrical engineers or engineers. She hopes to retire at 55. That's a nice young age to retire. With savings, she plans to make equal monthly deposits, and this is great if any of you can get into every month putting money away. At the end of each month for 20 years in a trust account that has a guaranteed interest rate of 9% per annum. That is a really nice high interest rate if you can get it from your bank. And it's going to be compounded monthly. She wants to have $300,000 at the end of 20 years. What amount must her monthly deposit be? Well, as soon as I see something to do with a regular deposit, equally monthly deposits, I know I'm using my new formula. But my R, I don't know. That's the whole point of this question, is how much should her monthly deposit be? This is not, she's not putting in $300,000 every month. So where does this number go? That would be our A. That's the final amount, $300,000. Let's list all of the other variables. We've got an R in the formula, an I, and an N. Okay, we already know the R is our unknown. But how about that I, the interest rate? So what does it say in the question about interest rate? It says 9% over a year, but it's being compounded monthly. So we've got to take that 9% and we've got to divide it by 12. We've got to break it up so you get a little piece of that 9% every month. That's going to be 0.0075. Now, N is how many compounding periods we have. So she was 20 years. She's going to put money away for 20 years, every month for 20 years. 20 times 12. 240. So let's sub it all in. 300,000 is our A, or our future value of our annuity. Did I miss a zero there? No. R, we don't know. That's the regular deposit. 1 plus our I value is 0.0075. The exponent is 240 minus 1. All over 0.0075. So we are going to have to isolate for R here. First thing I'm going to do is multiply both sides by, it's like cross multiplying. This is like if there's an invisible 1 under here, I'm going to draw an invisible 1 there. I'm multiplying that up, which does nothing. Really what I'm doing is multiplying the 0.075 up to the 300,000. So that'll be our first step. That's going to give us 2,250. And now we have R, and we can clean up the bracket a little bit here. This is 1 plus 0.0075 is 1.0075 to the power of 240 minus 1. So we're trying to isolate R, which means I now have to divide both sides by this big bracket thing here. 240 minus 1. They will cancel out. I'm going to do the same to this side. 0.0075. You don't have to write all of this out, of course. I'm just illustrating for you. So we get a value for R that is $449.18 for R. And we need a sentence because we had a word problem. We need word answer. The question said, what amount must her monthly deposit be? Therefore, her monthly deposit must be $449.18, which she would probably round up to $450. So she would probably be putting $450 away every month for 20 years. And then when she's done, she would have this lovely nest egg of savings ready. That is your lesson on future value of annuities.